So this was a last week class test about the motion Hooke's law and the topic turning effect or a moment. In the first question, a car which is having a mass of 1500 kg. So mass of a car is given, which is 1500 kilograms. A constant resultant force acts on the car and the car accelerates from 15 to 20. So the speed of the car changes. Originally it was 15 meter per second, then changes to 20. And how much time it took? It took 4 seconds to change its speed. We need to calculate the magnitude of the resultant force. If we want the resultant force, we can calculate by using our formula F equals ma. So F is equals to ma, force is mass multiplied by acceleration. The mass of the car is given 1500. What about acceleration? Is a change in velocity and unit time. So final velocity is 20, initial is 15, and how much time it took to change, that's 4. So it will be 5 divided by 4, which is equals to 1.25. So this will be equal to 1.25. So 1500 multiplied by 1.25. When we multiply, we get an answer, which is 1900 newtons. In question 2, a metal wire is loaded up to limit of proportionality. So when we load an object up to limit of proportionality, means it will obey the Hooke's law. And if we remove the load, it will return back to its original position. Like it will not if force and extension are directly proportional till the point of limit of proportionality, means when we remove the force, the object will return back to its original position. Like it will not deform permanently. Hooke's law is not obeyed. That is wrong, because if we are loaded up to limit of proportionality, it will obey Hooke's law. When load is increased beyond the limit of proportionality, the diameter of a wire will increase. That is wrong. Like example, if we have a wire till the limit of proportionality, we consider there is no deformation. But what will happen when we add, like there is no such difference or much difference is there, but when we add more load, what will happen to the wire? It will get thinner. The diameter will decrease, will not increase. That's why. So when the load is increased beyond the, like after the limit of proportionality, the diameter of wire will increase. That's wrong. It should decrease, because if you stretch the wire too much, then it will get thinner, not thicker. That's why B is not the right answer. When the load is removed, the wire will return to its original length. That's true, because within limit of proportionality, force and extension are directly proportional. If you increase force, extension will also increase. And once you remove the force, the object will return back to the same original length, shape, or size. Up to limit of proportionality, there is no change in shape of a wire. That's wrong, because what will happen when we apply a load, the object will stretch, there will be a change in shape. So this is also wrong. So option C is the valid answer. The diagram shows a uniform meter rule. Two weights are attached to this uniform meter rule, and it remain balanced. It means it is in equilibrium. So if an object is in equilibrium, what are the conditions? There should be no resultant force. There should be no resultant force, like resultant force should be 0. And if there is no resultant force, what is the direction of the resultant force? The direction of the resultant force will also be, like, it won't have any direction. Because if the resultant force is 0, then how it can have a direction? That's why direction of resultant moment and the direction of the resultant force should also be 0. As the object is balanced, there is no resultant turning effect, there is no resultant force. Or object is said to be in equilibrium. In question 4, the extension load for a spring shown. The unstretched spring is having a length of 17. When an object is suspended, the spring has a length of 19.2. What is a load? So this is a load and extension graph. It's not a length graph. So how much is the extension? Originally it was 17 and now 19.2. So when we take a difference, it will be 19.2. When we take a difference between them, it is 19.2 minus 17. So which is equals to 2.2 is extension. So 2.2 is extension. So this is each box is representing 0.1. So this will be 2.1. This one is 2.2. So from 2.2, we'll draw a line to work out how much load is attached to this. So from 2.2, when we draw a line on the graph, the load which is attached, that's equal to 3. So option D will be the right answer. When an object is moving in a circular path, it's always accelerating. And what is the direction of resultant force? Direction of the resultant force is always acting towards the center. Like if I say object is at this point, what is the direction of the resultant force? Towards the center. So it is independent of the position of the object. If an object is moving in a circular path, the resultant force is always directed towards the center. The next, a 20-meter long uniform bridge, which is having a weight of 100 kilonewton, is supported at each end by the pillars. The pillars exert a force T1 and T2. We have to work out the value of T1 and T2. Look, whenever two supports are there, as you can see, there is a support on the left hand side and there is a support on the right hand side. So any one of the support you can take as a pivot. Like example, if I'm taking the left hand side as a pivot. So any one of them you can consider as a pivot. So either you consider left hand side as a pivot or you can consider the right hand side as a pivot. It's up to you. It won't make difference to the final answer. So if I consider this left hand side support to be a pivot, so 24 kilonewton will cause a clockwise rotation, 100 kilonewton will cause a clockwise, and T2 will cause an anti-clockwise rotation. T1 does not contribute to any turning effect because it is acting on the pivot. And what are the moments? Moments are not only force, it's a force multiplied by perpendicular distance. So the car which is having a van, which is having a weight of 24, it's 5 meter from the left. So this distance is 5 meter. And the weight of this beam is 100 kilonewton. And how much is the distance? So if total is 20, the distance will be 10. So when object is in equilibrium, we always solve these questions by considering that the total clockwise moments is always equals to total anti-clockwise moment, or there is no turning effect. So the clockwise moment, that is 24 times the distance from the pivot, as we consider the left hand side pillar to be a pivot. So 24 into 5 plus 100 kilonewton. So this will be 100. Distance from the pivot, that's equal to 10. Then anti-clockwise moment is T2. And what about the distance from the pivot? The total distance, that's equal to 20. So T2 into 20. We need T2. We need T2, so it will be 24 into 5 plus 100 into 10 divided by 20. This will give us the value for T2. So the T2, after substituting, the T2 will come out as 56. So which option? T2 is equals to 56. So option C, T2 is 56. So we don't have to get for T1. That's the only option in which the T2 is equals to 56. So it's option C is the right answer. So how this 24 is causing a clockwise rotation? Because we consider this pillar to be a pivot. So when we consider this pillar to be a pivot and this pillar, we ignore this pillar. So as you can see, if I was having a beam, like this was a beam, so if this was a beam, a 24 Newton will cause a beam to bend or to rotate in this direction. So which direction 24 Newton is causing a rotation? If originally it is horizontal and rotate in this manner, so that's a clockwise direction, the direction of the clock. And which direction T2 will try to cause a turning effect? If it was horizontal, T2 will try to cause a turning effect in anti-clockwise direction. Is it clear, this question? How we worked out?
Yes, sir, clear.
So it's up to you. Any one of them you can take. You can also solve, like example, a student took right hand side as a pivot. Like another student solved the question and he took right hand side pillar to be a pivot. So if you took right hand side to be a pivot, then this will be ignored. Like this is not the pillar now. Now, what are the turning effect with reference to this pivot on the right hand side? 100 Newton will cause anti-clockwise. 24 Newton will cause anti-clockwise because originally the beam is like this, but because of the originally beam is like this, because of the 24 Newton or 100 Newton, it will rotate in this manner. So now this will cause an anti-clockwise rotation and T1 will cause a clockwise. And we solve in the similar manner. If this distance was 5, as I mentioned, so what is the distance from the pivot? That will be 15 because pivot is now on the right hand side. And this distance is 10 as weight is acting at the center. So again, the total anti-clockwise moment is equal to total clockwise moment. So it will be 24 times 15 plus 100 times 10. Why in this case 24 times 15? Because if I consider pivot to be the right hand side and the clockwise rotation is T1 multiplied by 20. When we solve, we'll get the value for T1. It will come out as 68. So only option in which T1 is 68, that's C. So C will be the right answer. So either you can consider the left hand side to be a pivot or a right hand side too. Whenever two supports are there, consider one of them as a point of rotation. In question 7, a spring which obeys the Hooke's law having an unstretched length of 10 centimeters. So there's a spring of length 10 centimeter. A load of 20 Newton is attached and the new length is 36 centimeter. So we add 20 Newton and it becomes 36 centimeter. What is the value of the K? The K is force divided by extension. So force is 20, but how much extension is there? Originally it was 10 and now it is 36. So it will be 36 minus 10, which is equals to 26. So the 20 divided by 26 is equals to 0.77 Newton per centimeter. In question 8, the diagram shows a beam which is lying on the ground. The end Q is lifted. So we lifted this end. The end P of a beam remain on the ground. So this point does not move. So means this is a pivot. The length of a beam is 3 meter and the weight is 600 Newton. The center of the mass of a beam is 1 meter from the end. So center of the gravity or center of mass is the where the mass or the weight is acting. So 600 Newton is acting here. Find the size of a force when just raise end Q from the ground. So even though practically this force should produce a greater turning effect than the clockwise, so this weight, a 600 Newton, is causing a clockwise rotation. And the upward force is causing an anti-clockwise rotation. But whenever we solve, we consider that the clockwise and anti-clockwise moments are equal. So the total clockwise turning effect is equals to total anti-clockwise. For such questions, the first step is identify the pivot. So we identify the pivot because they mention that NP does not move, it remain on the ground. So P remains stationary. That's the point around which the object rotates. So what is the clockwise rotation? The force is 600 and the distance we always take from the pivot. So that's equal to 1. So 600 into 1 equal to anti-clockwise rotation. The force is F and distance from the pivot is how much? That's equal to 3. So that is 3. So it will be 600 is equals to F into 3. 3 is multiplied, other side will be divided. So 600 divided by 3 is equals to F. So F is equals to 200 or option A will be the right answer. So whenever you solve such question, you will always consider the clockwise and anti-clockwise moments are balanced. The first thing you will do is identify the position of the pivot and then take all the distances from the pivot. The diagram shows a stand that hold a heavy mass above the bench. Which two changes would definitely make the stand? If you want to increase the stability, we should increase the base area and we should lower the center of the mass. So lower the mass, like this will lower the center of the mass and increases the base area. That will increase the stability. A footballer kicks a stationary football. His foot is in contact for 0.05 seconds. The mass of the ball is 0.4. The speed of projection of the ball is 25. What is the average force? So it was originally stationary, then the projection moved at a speed of 25, and the time it took for this change 0.05, and we have the mass. So first we work out the acceleration. Acceleration is change in velocity divided by time. So it will be 25 minus initial, which is 0 divided by time interval 0.05. This will give us the acceleration. And after getting the acceleration, we can use the resultant formula force. F is equals to ma. The mass is 0.4 and the acceleration will be 25 divided by 0.05. So this will be 200 newtons. Figure 2.1 shows an extension load graph for a spring. That is question 11. The point P is the limit of proportionality. Name the law which is obeyed by the spring from from origin to P. So that's a Hooke's law. Describe two features of a graph that shows it is obeying a Hooke's law. Number one, it is a straight line with a constant gradient, and number two, it's starting from origin. So it has a constant gradient or a constant slope, you can say. And the second thing, whenever it is obeying a Hooke's law, it should start from origin, like 0, 0. On a figure, sketch a possible continuation of a graph when the spring is loaded beyond the limit of proportionality. Like we add the load. So here, both are acceptable. They accept both. If you draw like load is increasing, extension increase, or you draw in this manner, both are acceptable. But the one which is not acceptable is this one. If you draw horizontal line, that is wrong. Or if you draw downward, that is also wrong. So both are acceptable because we are adding a load. So x-axis should increase. So both cases x-axis is increasing. So both are acceptable. But don't draw downward like some of the students, they draw this graph. That's wrong because if you are adding a load, extension should increase. It's not proportional, but it should increase. Define a moment of a force. The turning effect of a force is called moment, or in definition, you can also write a formula. It's a product of force multiplied by perpendicular distance from the pivot. Or if you write the turning effect of the force, that's also correct. around a fixed point or a pivot. The next question, figure 2.1 shows an object of negligible weight that is in equilibrium, means the clockwise and anti-clockwise moments. This sentence shows that the equilibrium means that clockwise and anti-clockwise moments are balanced. The object is free to rotate about its pivot P. So P is the point of rotation or a pivot. We have to calculate the force F, this force. First, we have to identify, look, a rope is there, so there will be a force from the rope, and that force is equals to weight of this mass. A mass is 50 kilograms. So what will be the weight? It will be 500, because mass multiplied by gravity, that's equal to the weight. So it will be 500 if we take gravity as 10. Otherwise, if you take 9.8, so it will be 500, 15 to 9.8. So this 500 weight is there. So it means this force on the rope is also 500. So this force on the rope is also 500 Newton. This is the point of rotation. Now to identify the clockwise and so if I just ignore this part because that's not related. Now I have to identify the clockwise and anti-clockwise rotation. So because of this 500 Newton, which direction it will appear to rotate? The clockwise. Because if an object is here, so this is an object. So this is an object. And because of this force, the object, the new position will be like this. So it means because of the force, it is rotating clockwise. So this is causing 500 is causing a clockwise rotation. And this force, which direction? This will try to cause a rotation that is anti-clockwise. But because it is in equilibrium, so the total clockwise is equal, the turning effect will be equal to total anti-clockwise. So clockwise turning effect, that is 500 multiplied distance from pivot. So we always take perpendicular distance between the force and the pivot, that's 20. Then the anti-clockwise, the force is F, we don't know. And the distance from the pivot is 12. So this is 12. 12 will multiply, the other side will be divided. So 500 multiplied by 20 divided by 12. If you convert the distance into meter, it won't make difference to the final answer. It will be same. But normally, because when unit cancel out, we don't convert them into unit. So when we solve, it will come out as 833 Newton, 833.3 Newtons. That is a force which this object will experience. Describe an experiment involving vertical forces to show how there is no net moment on an object in equilibrium. You may draw a diagram. So we need vertical forces to study moment. So what we can do, we can take a meter rule or a meter scale and we balance this meter rule, like place a pivot and we balance this meter rule. Then what we do, by using a string or a wire, we attach two loads, or we can place two loads on this meter rule at different positions and move the loads until it balances. And then we'll calculate the turning effect of the two loads. Like say this is W1 and the distance from the pivot is D1. This one is W2, so the distance from the pivot is D2. So we calculate the turning effect of the two loads, and the net turning effect should be same, like the clockwise and anti-clockwise turning effect should be same, or the net moment should be 0. So how you write this experiment, you can just simply, this is the open response question, like it's not having a fixed answer. You can write any experiment as they did not specify. So you can mention, we can take a meter rule or a meter scale, place on the pivot, then add two loads on different, like both sides, add two loads until the meter rule is balanced, then calculate the clockwise moment and anti-clockwise moment, and then we compare if the two moments. When the beam is balanced or the meter rule is balanced, the clockwise moment will be equal to anti-clockwise. Question 13. A ship sails in a straight line between the two ports. Figure 1.1 shows a speed time graph of a ship for 100 minutes. So here this time in minutes and speed is in meter per second. So whenever you use the value, you should convert time into second. Calculate the maximum acceleration during first 100 minutes. Maximum acceleration, because its acceleration is changing. Here, acceleration is increasing. Then it's having a constant acceleration. Then there is no acceleration. Which part we have a maximum acceleration? The part where we have a maximum slope. So this region, we have a maximum slope or a maximum acceleration. So what we can do, we can take 2 points. It says this region, because this region we have a maximum slope. So we can take any 2 points. Like I took this as first point, this one is a second point. The first point on x-axis, maximum slope means maximum angle. Slope is refers to angle. The question is, we need the maximum acceleration. The term maximum acceleration for a velocity time graph, the slope represent acceleration. If we need a maximum acceleration, so we need a region of a graph which is having a maximum slope or a greater angle with x-axis. So which region is having a greater angle with x-axis? So when you work out, like this was having a smaller angle, this region, and here the angle is 0. So which region is having a maximum angle with x-axis? That is from 40 seconds or 42 seconds to 40 minutes to 60 minutes. That's why we are taking this part to calculate the maximum acceleration. So here time is 40. This one time is equals to 60 minutes. So we have to convert into second. And what about the speed? If we take the speed, each box is representing 0.5. So 5.56, 6.5, about 7. So about 6.5 or 7 example. And this one is 15. So how to work out the acceleration? Acceleration is the change in velocity divided by time. Or you can work out by gradient, which is y2 minus y1 over x2 minus x1. But time should be in seconds. As the speed is in meter per second, so time should be in second. So this value is x1, but 40 is not x1. 40 multiplied by 60. Why multiplied by 60? Because it's 40 minutes. We have to convert into seconds. So 6 multiplied by 4, 24. So 2,400 seconds. This 60 is minutes. We have to convert into seconds. So multiply by 60. So it will be 3,600 seconds. So x1 is 2,400. X2 is 3,600. Y1 is 7 and y2 is 15. So we use the formula of the gradient y2 minus y1 over x2 minus x1. So it will be 15 minus 7 divided by 3,600 minus 2,400. This will give us the gradient, and gradient equals to acceleration. Or you work out the final velocity minus initial velocity divided by the time interval, the time difference between the two. Is it clear how to work out the acceleration and why we took only this part for the maximum acceleration?
Yes, sir. Clear.
Okay. The next part, to calculate the total distance traveled by the ship between 24 minutes to 100 minutes. So to get the speed time graph, to calculate a distance travel, we have to calculate area under the graph. So from 42 minutes, each box is representing 2. So this one is 42. So what shape it is making, it's having multiple, like the total area under the graph is refers to the distance travel, like this whole area. So this total area under the graph is refers to the distance traveled by the object.
So, Mister, we can divide it into trapezium and rectangle.
Yeah, either trapezium into rectangle, or you can divide into three figures: triangle, rectangle, and rectangle. It's up to you. What is easy, what you find easy. Like this is 1, 2, and 3. But again, in this question, time is in minutes. You should have in second. Like you have, if it is like 42 minutes, you have to convert all in second because the speed is in meter per second. So first, it's a triangle. Like I take a triangle. So it will be half base. How much is the base? It's starting from 42 and ending at 60. So how much is the base? It's 80. Multiplied by height. We cannot make into small square because this is not a non-linear graph. When you have a curve or a non-linear graph, that time you divide into small squares and then work out the area of each square and multiply by number of squares. In this one, it's a straight line graph, linear graph, so you have to divide into specific shapes. So it is 18 and the height is how much? Like it's starting, this is 7.5. 6, yeah, this is 7.5 and ending at 15. So it is 7.5. So 7.5. But see, from 42 to 60, it's 18 minutes. But time should be in seconds. So I have to convert into second. So I have to multiply 18 first with 60. So that it converted into second. And then, so this is a base and then the height is how much? That is 7.5. So this is the area of the triangle, the figure 1. Then area of the second figure, like this rectangle, it's starting from 60 and ending at 100. So that is the second figure is equals to 40. But this is 40, but that is in minutes. I have to convert into second. So 40 multiplied by 60 to convert into second. Then, so length, so this total length is there, and then height is how much? Starting from 7.5 and ending at 15. So again, it is 7.5. So we multiply, we'll get the area of the second figure. And then for third figure, it's starting at 42 and ending at 100. So it's equal to 58. So 58, but again, 58 minutes, we have to convert into seconds. So first we multiply by 60 to convert into second. And then we multiplied by the height, which is 7.5. This is one way of doing this. Or the second way, what you can do, you work out the area of the each figure and then multiply the last answer by 60. So it won't make difference. You will get the same result. So find the area of each shape and then sum them to get the total, which is about 48,000 meters. So when you add area of each, it will be. Now in the question, we are supposed to start at 42 because in the question they said that what is the distance travel between 42 and 100 minutes. That's why we started with 42. If the question was what is the distance travel from 40 to 100 minutes, then we'll start with 40. So 40 to 100, we'll start with 40. They asked for 42 to 100. That's why we are starting at 40. There's no other way. You have to solve in this way only. Like there's no other way to solve such question. You have to find area under the graph. So you have to divide this figure into small parts. You may have triangle. So find area of the triangle. How to find area of the triangle? It will be half. The base is equals to 18 and the height is 7.5. You get the area of this part. That will be, Yeah, that is like find area of this part, then area of a rectangle. It is starting with 60, ending at 100. So it is 40 multiplied by the height, which is 7.5. And this one starting at 42 and ending at 100. So it is 58 multiplied by height 7.5. Find area of each of them, like triangle plus rectangle, and then the final answer. What final answer you get, you multiply that final answer by 60. So that will also be same. It won't make difference. So you can convert in between or you convert at the last. Both will be same. Then calculate the resultant force. So we have the formula F is equals to ma. The acceleration is there, the mass is there. So 2.3 into 10 to the power 7 multiplied by acceleration 0.0087. You multiply, you will get the force in Newton, which is about 200,000 newtons. Yeah, 200, rounded off answer is 200,000. Explain why the force on the ship explain why the force on the ship due to the ship engine is greater than the value we calculated. Because we did not consider any friction, we did not consider any drag from the water. So there will be force of a friction or a drag force or a water resistance is there. So we did not consider, we just consider the force needed to accelerate is 200,000 Newton. But in practical, the engine should apply more force because there will be a force from the water or there will be a water resistance, which you can also say drag. So drag will also act, or the water resistance oppose the motion. That's why the in practical, the force of the engine will be much higher than 200,000 Newton.